All right, let's look at this problem called product of array except self. Let's have a read. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must set an algorithm that runs in O of n time and without using the division operation. All right. So 1, 2, 3, 4. For 1, I have to return the product of 2, 3, 4. For 2, I have to return the product of 1, 3, and 4 for 3, and so on, right? So the problem, like in a naive or a brute force way, what I would do is two ways. One is I would just like if for one, I would basically I could do an square solution where I select one separately. So for one, I would multiply these three, and then for two, I will multiply 1, 3, and 4. But that would be n squared, and that would break this condition. Second option that I could do is I could multiply all everything, right? I could multiply everything, keep that in a variable, and then what I would do is for every guy, the total whatever total multiplication is, I will then use that and divide it by the value at this index. But it says without using the division operation. So both those basic intuitive approaches that come to your mind have been sort of neglected, have been discarded. They have not been allowed. So what else we can do to find the product of some the hint part of the hint is there in the question where it says the product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. So could we use product of prefix or product of suffix? Um, and could we maybe use an auxiliary space that would maybe save product of prefixes or product of suffixes? Mm. So let's try and come to maybe a whiteboard and see if we can do something of that sort. So the first example that is given to us is a 1, 2, 3, 4. That is the array. Obviously, the answer we can clearly think is for 1, the product of array except self would be 3 times 3 to the 6 times 2 is 24, and this is would be 12, this would be 8, and this would be 6, right? This is what we will get. So essentially, what we want, if we sort of simplify it, so um, corresponding to this, we want 2 times 3 times 4. Corresponding to this, we times 1 times 3 times 4. This is 1 times 2 times 4, and this is 1, 2, 3. Now, let's sort of divide it. So what this is okay, 2, 3, 4. What this is 1 and 3, 4. What this is 1, 2, and 4. And what this is 1, 2, 3. Right? So this is prefix, sorry, this in this case is suffix. This is prefix, suffix, prefix, suffix, prefix, suffix is 1. Here prefix is 1. Right? So for every guy, if we can get the prefix and the suffix multiplications, right, then we just then we can get it, right? So a simple way is for every guy get these prefix and suffixes. So for 1, 2, 3, 4, let's build this prefix and this suffix arrays, right? So a prefix, what would be a prefix value? What would prefix mean? Prefix mean I probably you'll have to start with self, I guess, right? So for this, maybe you say it's 1, then 2, then 6, and then 24. What would suffix means? Maybe I start from here, so it will be 4, and this will be 12, this will be 24, and this will be 1, right? And obviously there is a slight problem where here prefix and suffix are including self, right? If these prefix and suffixes were excluding self, then it would be quite basic and quite clear. But what we could potentially do is so here what we could do is essentially so prefix includes itself. That would mean that I would want to use one before, and so one before there is nothing, so one times for suffix the next guy, right? So for this it will be 20. So this times this, which will be 24. For this it would be this and this, so 12 times 2. Sorry, 12 times 1 is 12, right? And for index 3, it will be 2 times 4, which will be 8. For index 4, it will be 6 times the next guy, which is not there, which would be simply 6, right? So that is a basic way of doing things. Uh, so let's start with that basic approach. All right. So now what we're saying is, but if you notice something, for prefix, we went one step back. Let me come back. Okay. So if you notice for prefix, we never used this guy. It was of no use. For suffix, we never used this guy. It was of no use. So if we could just shift the prefix by one, then this an out of array wouldn't happen. So if we say prefix as uh, basically something, so if I modify the definition of prefix with instead of including, if I make it excluding, what would it mean, right? And let's build that. So let's let's take the array again. So we have 1, 2, 3, 4, and this is prefix, this is suffix, and both now we are saying is excluding. So when you exclude, one thing that's clear is, hey, prefix multiplication, when I'm excluding one, that I mean you have to initialize this to one. There is no other option. Similarly, suffix multiplication, when you are excluding this guy itself. So for suffix of and will also be one. Like that is something that you will initialize regardless, right? And then you could add multiple, like you can use the other things. So for example, for here, this is the prefix excluding. So when prefix you're excluding, it will just be 1, then it will be 2, and then it will be 6, right? And that's all because you're excluding the noded here. So for this, it will just be this. For this, it will just be these two. For this, it will just be these three as the prefix. Similarly, for suffix, so when you're talking about suffix, we start from right to left, try to build a suffix like that. So we initialize it to 1, which is fine. And then we get here, you take this guy and multiply it with this guy. So you get 6, then you get 12. Oh, I'm multiplying wrong stuff. Yeah, so you get 4. You're looking at the array, right? So you get your 4, then you get your 12, right? So, I mean, for 3, you're just looking at this. For 2, you're just looking at this. For 1, you're just looking at this. So, which is 24. If you do that, then it just becomes easy for your product except self. Product excluding it, then it just becomes okay 24, 12, 8, and 6. So if you can build based on that manner, right? And let's try to use this strategy for building the prefix and suffix array. Coming back to the code, so we have let's say an integer array called prefix, and we'll do it as new int length, and we also have suffix. We'll set up as length. Now we're gonna do is like we said, prefix of 0 obviously was 1, and then we'll do for I equals to 1, I less than nums.length, I plus prefix of I equals to prefix of I minus 1 times the nums of I minus 1, right? Exactly. Excluding self, we have to go n minus 1 only. And this should work. And now let's do suffix. So we'll set suffix of n minus 1 equals to, or rather, nums.length minus 1. This we'll set as 1, and now we'll do I equals to nums.length minus 2. I is greater than equals to 0. I minus minus. Suffix of I equals to, so you're gonna start with suffix of I plus 1 times nums of I plus 1. So now that is, both of these are set. Then finally you can take answer equals to new int nums.length, and you can just do for I equals to 0, I less than nums.length, I plus plus. Answer of I equals to prefix of I times suffix of I, and you return answer. And let's run it. Fix the compilation errors. See what's the issue. Answer it doesn't understand because we were lazy a little bit. All right, run and submit. And it seems to work. Now, I think if we talk about the time complexity and space complexity, it's just overfan and overfan. If we want to optimize it a little bit, like we could potentially avoid using some of these arrays and do some other things like in place. For example, we anyways need this integer. We already need to assign like an answer array, right? So uh, could we save like the prefixes in answer array and suffixes in maybe the original array, and like save on some space that way? Could that be something that can potentially be done? So obviously one of the things that could be done is, okay, you could definitely save this answer array, like and just maybe use one of the prefix or a suffix arrays. So you could just do like you could maybe just do prefix of I equals to prefix of I times suffix of I, and then you could potentially just return your prefix array, that sort of a thing. Say one array allocation. I don't know if that is an optimization, but definitely you can do something of that sort where, okay, say on the array allocation, can we save some more space? Like, can we avoid maybe the suffix array as well? Let's see. I think this is good enough, no? So you definitely need to have the prefix array, like one of prefix or suffix is needed. Only thing is, okay, maybe um, between prefix and suffix, you could maybe potentially avoid one more. Like definitely you could avoid. So let's see if we can avoid this suffix array or not. Let's try and see. That's something that is doable. So prefix we do and we build it. Now instead of the suffix, can we update? And also the number of loops, right? So we build the prefix, which is fine. Now, while building the suffix, can we also update the answer? Interesting. I think so. Like, I think we could avoid these two loops, but for that, I would need a suffix array though. So I could do one of the things that I'm thinking is like, why do I need this here? I could potentially just so when suffixify is made this, that means what? Yeah, so the prefix of I minus one would be anyways the yeah. So basically just do this and then do prefix of the same thing. So prefix of I equals to, you could potentially just do this and then avoid this for loop, right? Let's see if this works. And this gets accepted as well. Um, what else can we improve upon? Like clearly here, when we're saying suffix of I, we don't really need this suffix of I array, I feel like, right? Because you could just do like an int suffix equals to, or just you can do, you could initialize suffix to one, and then you could do suffix equals to suffix times nums of I plus one, right? Because suffix at any point would be um, excluding myself, so I plus one always has to be there. And yeah, and so you go prefix of I equals to prefix of I times suffix at this index. And so now you save on even more space. So submit this. Yeah, I think this probably is the best. You now are taking one auxiliary array, you are building it. So there are one loop to build the prefix and the other loop to build the suffix as well as the answer. And for a suffix, you're not using any auxiliary space because you just need a variable. I think that's the best that I can do. All right. So just submit again and that's it. And it keeps on varying, but I think we are good.